This is question, guys. So if I will tell you AD value. So AD value of RIP is 120 and AD value of EIGRP is 90. So for R1, which one is best?
Uh, the lowest EIGRP.
EIGRP, yes, lower one. So router will install these prefixes via router number 3 because of lower AD value. If you want to see, I can configure this topology. It is very simple. First of all, I need to configure the IP. So interface F0/0 no set and IP address over here will be 12.1.1.1 255.255.255.0 exit and interface F1/0 no set and IP address is 13.1.1.1 255.255.255.0 exit router RIP version 2 no auto summary and network 12.1.1.0. See, I have enabled RIP only on F0/0 and I am going to enable EIGRP on F1/0. So router EIGRP, after that AS number, autonomous system number here. To enable EIGRP, just you need to type router EIGRP and then autonomous system number. Autonomous system number range is 12655535. So let me use number 10 over here. And then again network 13.1.1.0 0.0.255. As I told you, in EIGRP we have concept of wildcard mask. So see, I am advertising this network with this wildcard mask. Actually, I am telling to router 1, please match first 3 octet. Yes or no? Yes, guys.
Yes.
Yes.
Done.
Yes.
Sir, why did you choose 10 for EIGRP?
Any number you can choose
What
here.
does it mean? What does it mean? Like,
It means EIGRP work on the basis of autonomous system. Soon we are going to discuss autonomous system as well. Just wait for some time, okay? We will discuss autonomous system as well. Let me exit over here and do so history. Do so history. Let me copy the command. Oh, IP configuration is not there. Leave. So configuration of router 1 is done. This is how we configure EIGRP and RIP. See, now you have configured EIGRP on router number 1 with AS number 10. So AS number should be same on router number 3 also and on router number 4 also. Then only EIGRP neighborship will work. In case of RIP, when we are configuring RIP, simply RIP is not forming any neighborship. RIP is directly forwarding update message directly. But in case of EIGRP, when we configure EIGRP, first router will become neighbor. First of all, two router will become neighbor. For becoming neighbor, they will check some parameter. If parameter will match, then only two router will become neighbor. Parameters are, first parameter is AS number. AS number should be match, or you can say AS number must match to form EIGRP neighborship between two router. Okay. So now I am going to configure, let's say R2 and then R4, then R3. Okay. Enable config T interface F0/0 say no set and IP address over here is 12.1.1.2 255.255.255. 0 exit interface f1/0 no set, and IP address over here will be 24.1.1.2 255.255.255.0 exit router RIP version 2, say no auto summary, and network I can run 0.0.0 command over here, because on router number 2 you can see all interfaces are in RIP. Now let me take you to R4. Config
Sir,
T.
no, you are doing like a REP or EGRP.
This is my EAGRP. Just I want to make you understand the AD value
Okay.
of both protocol. So I have a topology. See, upper path is using RIP routing protocol, lower path is using EIGRP protocol. So just you need to compare that which protocol is best for R1.
Okay.
IP address 24.1.1.4 255.255.255.0 exit interface f1/0 no set, and here IP address will be 34.1.1.4 255.255.255.0 exit router RIP version 2 no auto summary, and network, which network, 24.1.1.0, and I need to advertise this network as well, these 40 prefixes, yes or no. In both routing protocol actually we are going to advertise this network in AIGRP also and in RIP also. So 40.1.1.0, 40.1.2.0, 40.1.3.0, and 40.1.4.0. I have advertised all network. Now router EIGRP S number 10 network 40.1.1.0, 0.0.255, 40.1.2.0, 40.1.3.0, and 40.1.4.0. I have advertised these 40 network in both routing protocol, in RIP also and in EIGRP also. But now there is no neighborship, there is no any connectivity between router 1 and router 3. If you will check routing table of R1, you can see so IP route. It is not receiving 40 prefixes, by the way. It is receiving 24, it is not receiving 40 prefixes. Soon it will receive 40 prefixes as well, guys. Just wait for some time. On R4, let me check. I have run how many command here. So these are fine. 24.1.1.0 is also fine. So everything is fine, and here just I need to create this loopback. Actually I have not created this loopback over here. So interface loopback 1 and IP address 40.1.1.1 255.255.255.0, then interface loopback 2, and IP address is 40.1.2.1, interface loopback 3, and IP address is 40.1.3.1, and interface loopback 4, IP address is 40.1.4.1. So now router 1 will have root. Yes, you can see all 40 prefixes, yes or no. Via which router? Router 1 have learned these prefixes via which router? Via router number 2, because next hop IP address is, you can see 12.1.1.2. This is the IP address of router 2, and AD value is 120 and metric is 2. Metric is 2. Is it clear, guys, to everyone till here? This is concept of RIP.
Yes. Yeah, so you configure
Yes.
EIGRP, right?
I have
So
not
here,
configured EIGRP on R3 now.
okay.
Once I will configure EIGRP on R3, R3 will also start advertising this network to R2, R1. Then R1 will flush this network
Okay,
via router
because
number 2. It will
yeah, because
install
we are,
via router number 3.
yeah, that's why we only can see like AD value of rep, not in
Yes.
EIGRP.
So
Okay,
now till here clear, everything should be clear to you. That
yes,
router 1 is receiving these all prefixes via router number 2 working fine. RIP is working fine. Now let
yes,
me configure EIGRP on router number 3. Let me take you here. And on any router, this is R3. Where is R4? On R4. In router you can check so IP, EIGRP interface and brief interfaces. So by running this command we can check the EIGRP enabled interface on router. So you can see EIGRP is enabled on all loopback interface. Let me enable EIGRP on F1/0 of router 4. On this interface also I need to enable EIGRP. Yes or no? Because this interface is in EIGRP domain. So let me run one more command on router number 4. That is a router EIGRP AS number 10 and network. What network is running there? 34.1.1.0.0.0.255. Done. Let me take you to R3. On R3 first I will configure IP address, config T, interface F0/0 no set, and here I will configure IP 13.1.1.3 255.255.255.0 exit interface F1/0 say no set, and IP address here I will configure IP 34.1.1.3 255.255.255.0. Done. Let me configure EIGRP. So router EIGRP ES number 10, and we need to run two network command 13.1.1.0 wildcard mask, and one more network command that is 34.1.1.0 Are you able to see the log message as well here? EIGRP IPv4 AS number 10 neighbor 13.1.1.1. So it have formed one neighborship between router 1 and router 3. Once I will run this command, it will form one more neighborship with router 4 with 34.1.1.4. Getting my point, guys? Here you can
yes,
run, as I told you that EIGRP routers maintain three types of table: neighbor table, topology table, and routing table. First of all, router will become neighbor. So IP EIGRP neighbor. By this command, we can check who is neighbor of R3 in EIGRP. So you can see in EIGRP there are two neighbor. One is 34.1.1.4. This is the IP address of router 4, and another neighbor is 13.1.1.0. This is the IP address of router 1. Now again I am going to show you the routing table of R1. Earlier you were able to see these all prefixes are reachable via router number 2, and now again show IP route. Now this time you can see this router have installed all prefixes via which router? Router
router
3,
3,
13.1.1.3, and AD value is
90.
90, means AD value of EIGRP is 90.
But what about the metric?
And metric is this one. So we need to understand how router 1 have calculate this metric.
Mm-hmm.
Okay, we will discuss metric calculation.
Okay.
So metric is third thing, right? First it will check AD value, then metric. So first
Yes.
router will check AD value. AD value through RIP is 120 and AD value through EIGRP is 90. So it have installed which path? This path. If let's say this interface F1/0 will goes down, again it will install 40 prefixes via RIP via router 2, because router 2 is still advertising those prefix. You want to check, so IP RIP database In RIP database, we are able to see all 40 prefixes on router number 1. Yes or no? So these 40 prefixes are there in the database of RIP, but not in routing table. In routing table, we have these prefixes through EIGRP. Done. So if a router are getting same prefix from two routing protocol, one from RIP and one from EIGRP, so router will consider which routing protocol?
AIGRP.
EIGRP. Okay.
Is it because of the AD value?
Yes, it is because of
Okay.
the AD value only.
Okay.
Because first of all, router 1 will check what longest prefix match. So prefix length is same 24 via both sides, from RIP also and from EIGRP also. Then router 1 is going to check AD value. So AD value of EIGRP is 90 and AD value of RIP is 120, and as you know, lower value is best,
Yes.
right? If AD value is also same, then it is going to check metric. So here we have, you can see large metric than RIP, but a still router have installed prefixes via EIGRP because of AD value. Because router compare AD value first before metric. Getting my point? Now question
Yes.
is how routers calculate metric in RIP, in EIGRP. In RIP it is clear how routers calculate metric, right? So guys,
Yes.
formula to calculate metric in EIGRP is pint. Let me write here. Formula to calculate metric in EIGRP is very simple. It is metric is equal to 10 to the power 7 upon list bandwidth plus total delay upon 10 and whole multiply by 256. This is a formula of EIGRP to calculate metric. Now, as I told you, see, EIGRP is using link bandwidth, link delay to calculate metric. This is good. Yes or no, brother? Because in distance vector routing protocol, in last class also we discussed that maybe longest path can be best path, but RIP cannot understand that because RIP don't have capability to calculate metric on the basis of link property. But here EIGRP have capability to calculate metric on the basis of link properties. Okay, so in this topology, guys, here, see, I have created some loopback over here on router number 4. Done. I have one loopback here 40.1.1.1. Done. This is loopback on router number 4. So router 4 will calculate one metric for this interface. Metric formula will be 10 to the power 7 upon list bandwidth. So bandwidth of, it is not comparing, bandwidth of link. So let me check what is the bandwidth of loopback interface on router number 4. How I can check bandwidth? So interface loopback 1, and we can say include bandwidth only. So this is bandwidth in kbps. So in mbps what will be the bandwidth? 8000. Am I right? So we need to write here in kbps. So let me copy it and I am going to paste it over here. 10 to the power 7 upon this metric. Sorry, this is bandwidth plus delay. So delay of this interface is, you can see over here, delay of Loopback interface is very far, 5000. Yes or no? So delay is 5000. So 5000 divided by 10 and whole multiply by 256. Can anyone calculate it? What value you will get? See here I can write 10 to the power 7 upon 8 multiply by 2 to 4 to 6. 10 power 6. Yes or no? 10 power 6 plus 5000 divided by 10 will be 500 and whole multiply by 256. Can anyone calculate this value? Here we can reduce it. So 10 upon 8 plus 500 and whole multiply by 256. Can you calculate this value? Anyone?
Give me a second. Okay, I will try.
Okay.
Yeah, it looks like 128320.
Okay, let me check. Here, just I want to check what is metric on loopback one interface. For that, show IP EIGRP topology. I can run this command and see the metric is this one. This one is the
Yeah,
metric.
yeah, 12,800 or no, 128320.
No, this is metric. I think there is some miscalculation.
Maybe. Yeah.
This is metric. Okay, let me do one thing. Let configure metric on fast Ethernet link. Let me delete it and let me do one thing. Here I am going to delete upper scenario. Right, this I am going to delete R2 here. Now we have only EIGRP. Okay, and let's say here I have one switch. Here let's say I am using any network. Which network you want to use? Let's say I am using 10.1.1.0/24. This is network over here. This is R1, R3, R4. I'm running EIGRP. Okay. Now on R1, I think I need to change the IP configuration. Config T interface F0/0 and IP address is 10.1.1.1 255.255.255.0. I'm going to say no router RIP. I have removed the RIP configuration. Now we have only EIGRP configuration. From router number 4 also I am going to remove RIP configuration. Config T and say no router RIP. Done. Now this is my topology. So see guys, here once I will advertise this interface in EIGRP, router 1 will calculate metric first. So for metric calculation formula will be same, 10 raised to power 7 upon list bandwidth plus total delay upon 10 and whole multiply by 256. Okay, so very clearly please calculate metric over here. I am going to show you the bandwidth and delay. So interface F0/0 include bandwidth. See, this is bandwidth and this is delay. Please calculate very carefully. Formula will be 10 raised to power 7 upon 10 raised to power 5 plus 100 upon 10 and whole multiply by 256. Please calculate this value and let me check values are matching with your answer or not.
28,160.
Done.
Yes, 28.
Let me check.
28,160.
So IP, EIGRP, topology, and then we can say 10.1.1.0. So IP, EIGRP, topology, I think 10 network is there and metric is this one. This value, brother?
28,160. Yep.
Hmm?
Yes, the same. Correct.
Same value. So see, this is how EIGRP calculate metric. After that, what we R1 will do, R1 have calculate one metric for this network which is running on this interface. After that, it will share one update message to their neighbor. And in update message, it will share with this network 10.1.1.0/24. With this network, it will send bandwidth and delay. So bandwidth is 1, 2, 3, 4, 5 and delay is 100. It will share these two information in the update message. When router 3 will receive it, it will also calculate metric, yes or no? Router 3 will also calculate metric to reach in this network. So formula is 10 to the power 7 upon least bandwidth. Now, least bandwidth means bandwidth which is coming in update and bandwidth of my link. So bandwidth which is coming in update is 100 Mbps and bandwidth of my link is also 100 Mbps because both links are fast Ethernet link. Yes or no? So on R3 also if you will check bandwidth, so bandwidth will be same. On
Is it
R3,
important to learn some? Is it important to learn these things like the bandwidth or something like
yes,
the?
it is important that how EIGRP calculating metric.
Okay.
So interface F0/0 include bandwidth. See here also bandwidth is same because we are using fast Ethernet link everywhere. So means router 1 is sending update message. In that update message, router is sharing prefix and with prefix it is sharing bandwidth and delay. Now router will compare their bandwidth which is coming in update and their own bandwidth of link, receiving interface link. So bandwidth of receiving interface and bandwidth which is coming in update both are same. So it will use any number, this one 3, 4, 5 plus total delay. So delay of my interface is 100 and delay which is coming in update is also 100. So total delay is 200 upon 10 and whole multiply by 256. This will become metric on R3. Is it clear? Please calculate it what metric you will get on R3. Tell me guys what will be metric on R3.
30,720.
So IP route EIGRP for this network. This one.
Yes.
On R4 what will be the metric? On R4 what will be metric on R4 guys? So IP route EIGRP. So this is metric on R4 because when R3 will advertise this network 10.1.1.0/24, it will share least bandwidth till R3. So least bandwidth is 100 Mbps or you can say this is in kbps, right? and then delay, total delay. So total delay is 200. Total delay is 200. Now R4 will use this formula, same 10 to the power 7 upon least bandwidth. So bandwidth which is coming in update is 1 lakh, and bandwidth of my interface is also 1 lakh, so 10 raised to power 5 plus total delay. So delay which is coming in update is 200 and my interface delay is 100, so total delay will be 300 upon 10 and whole multiply by 256. Done.
Yes.
Is it clear how EIGRP is calculating metric?
Yes.
Yes.
So let's say if I have one more router over here, this is your homework, and here we are using serial link. Serial link have different bandwidth, different delay. So now you need to answer what will be the metric on this router on R2 for this network 10.1.1.0. If you want to check the bandwidth of serial link, I can show you. On R4, simply I can run command show interface, so interface serial 2/0, and we can say include bandwidth. You can see bandwidth of serial link very less and delay is very large. So can you calculate metric on router 4?
Yeah. So if the bandwidth is low
Yes.
and delay is high, is it good
Yes.
or bad?
Bad link, it means it is bad link.
Okay, bandwidth is
Delay should be less on the link, right? Means your traffic will flow quickly.
got
This
it.
is delay. Delay should be less, yes or no? And
And
bandwidth should be high.
Okay, got it.
So on serial link you can see bandwidth is less and delay is high. Here what will be the metric? Can anyone tell me the formula? Ten raised to power 7 upon least bandwidth. So bandwidth which is coming in update is 100 Mbps and bandwidth of receiving interface link is 1.5 Mbps. Yes or no? Plus total delay upon 10 whole multiply by 6. So see, whenever your bandwidth is least, bandwidth is actually inversely proportional to metric. So if bandwidth is least, then metric is high. And if bandwidth is high, then metric is low. And as you know, lower metric is more preferable. Getting my point? Getting my point, guys? Is it clear?
Yeah, it's
Yes,
clear.
clear but confusing.
Confusing?
Yeah.
Just you need to, practice by yourself of calculating metric. Then it is very easy. But it's not difficult. EIGRP is really difficult as compared to RIP protocol, but it is important to learn. Okay, so now I am going to start EIGRP. These were just overview. Understand how EIGRP works because we have lots of things in EIGRP. So let's say I have brother 2 router 1, router 2. R2. Here I have let's say using IP 12.1.1.1, and here IP address is 12.1.1.2. Done. Once we will run command here, router EIGRP AS number. Now question is, try to understand what is autonomous system number. Guys, autonomous system number is just a domain, means just area. It is an area. Let's say, let me take one example here. Let's say we are talking about one society or residency. Is it clear? Let's say this is one society, and name of the society is anything, XYZ society. This is XYZ society. Done. In this society, let's say few peoples are living, and in this society two people are living whose name is, let's say, Ram or A, person A, and one more person is living, that is person B. Guys, what will be the rule and regulation? Like whatever rule and regulation is of the society, like electricity bill, right, maintenance, everything, whatever rule are there, those rule will be same for both of the person A and person B. Yes or no? Because both are living in same society, so both rule and regulation of society will be same. Am I right?
Yes.
Like rule can be, after 10 o'clock in the night you cannot enter in the society, or you cannot speak loudly in the society in the night. This can be the rule. Done.
Yes.
So whoever live in this society, that rule will be applicable for all people. Yes or no?
Yes.
Now, how you will identify that these two person living in same society? If you will ask to this person, hey person A, where do you live? He said, I am living in XYZ society. If you will ask to person B, hey person B, where are you living? If he will also say, I am living in XYZ society, then you will came to know that, oh, both belongs to same society. In the same way we have autonomous system number. Autonomous system number is also a domain, and all the router who belongs to this autonomous system domain, routing policy will be same for all router. Here rule and regulation is same, here routing policy is same for both router, for all the router who belongs to this domain. Getting my point?
Yes.
A domain where routing policy will be same on all routers. Now how we will identify both router belongs to same AS number or different AS number? So like you can see, person have name, person A and person B, we have autonomous system number. If I am using autonomous system number 10 over here and 10 over here, so that means both belongs to same AS. Getting my point? Means routing policy on both router will be now same. But if I have two router R1, R2, here I am using AS number 10 and here I am using AS number what? 20. So tell me, both routers belongs to same AS or different AS?
Different.
Both belongs to different AS. So routing policy will be also different. Getting my point?
Yes.
So EIGRP work within autonomous system number. If both router belongs to same autonomous system number, then only EIGRP will work. Getting my point?
Yes.
Between different OSPF, between different AS number, EIGRP cannot form neighborship. Okay? So this is concept of autonomous system number. Autonomous system is 16 bits value. It is 16 bits value. ASN. Autonomous system number, it is 16 bits value. So range can be 02655 1265535. This can be the range. Is it clear? So this is first thing about EIGRP. EIGRP work within autonomous system. Let's say in this topology, now you can see R1 is learning all 40 prefixes. Yes or no? All 40 prefixes. So IP route route EIGRP. It is learning these all 40 prefixes. And here I am running what AS number? So IP protocol. I am running AS number. Here you can see AS number 10. Means on all daughters I am running AS number 10. If I will run AS number different over here, so IP EIGRP neighbor. So neighbor is 13.1.1.2. If I will run different AS number over here, say no router EIGRP AS number 10. I have removed AS number 10 configuration and let me run router EIGRP AS number 20 and network 13.1.1.0 while karma 0.0.255. See, OS EIGRP neighborship will not come up. Why? Why? Because of AS number mismatch. On router number 1, AS number is 20. On router number 3, AS number is 20. 10.
So we have to apply the same ES number in all router.
Same AS number on all routers.
Okay, if we apply a different ES number, then they're not gonna connect each other.
Yes, then it will not connect each other. Then we need to perform redistribution. That is, upcoming topic.
Okay.
For now, just think that EIGRP will work. EIGRP works within AS, within autonomous system. Between autonomous system number, EIGRP nodes work.
Okay.
Okay.
And we have to do that one. We have to apply
Yes.
ES number.
Yes.
Okay.
And you already know how to EIGRP calculate metric.
I don't like
For
that.
metric calculation, by default, it is using bandwidth and delay. Yes or no?
Yes.
Bandwidth and delay. So now guys, see here. This is my topology. Here on router number 1, I am running command router EIGRPS number 10. After that, I will run network command. Network 12.1.1.0 and then while karma 0.0.255. This will be the command to enable EIGRP on router number 1. Yes or no? Is it clear to everyone? Once I will hit enter after a network command, what router 1 will do? Router 1 will send one hello message. It will send one hello message. Inside the hello message, it will share their AS number. My AS number is 10. Getting my point? On what address? On multicast address of EIGRP. If you want to see the multicast address of EIGRP, simply on any router you can run command show IP interface fast ethernet 0/0, let's say. So you can see this is multicast address. Where is the multicast address of F1/0, I think. Multicast address of EIGRP is 224.0.0.10. So it will send this hello message on 224.0.0.10, this address. Okay.
So this multicast address is default for EIGRP.
Yes, this is default for EIGRP. Like for RIP version 2, we have one default multicast address 224.0.0.9.
Okay, got it.
Have you remember?
Yes.
Yes, like that I have one reserved multicast address for EIGRP, that is 224.0.0.10. Done. And now EIGRP is not enabled on router number 1, so maybe router 1 will discard it. But when I will run here also command router EIGRP AS number same 10 and network 12.1.1.0.0.0.255. Done. After running this command, router 2 will receive this and it will also send their hello message. It will also send their hello message to router 2. In their hello message also it is nothing but hello message. This hello message will carry which information? AS number. AS number is 10. So see, both router will check the neighbor AS number. So if neighbor AS number and their own AS number will match, then only these two router will become neighbor. Getting my point? Now you can see over here AS number in the hello message of router 1 is also 10 and AS number in the hello message of router 2 is also same. Yes or no? So both router is going to become neighbor. Now both router will become what? Neighbor. Now we are neighbor. We can exchange the network information with each other. Done. But on router number 2, if you will run AS number 20, so inside the hello message of router 2, AS number will be 20. When router 2 will receive this hello message, it will check the AS number. Oh, here AS number is different. Router 2, you can't form neighborship with me. It will discard it. Like that. Getting my point? Okay, guys. After becoming neighbor, router exchange the update message. Let's say router 1 have some network information here. 10.1.1.0/24. So router 1 will send one update message to router 2. And in this update message, it will share this network information 10.1.1.0/24. So network information, router send a network information to their neighbor router only. So first in EIGRP, it is important to form neighborship. EIGRP routers are not going to directly exchange routing table like RIP. Clear? Clear, guys?
Yes.
Yes.
First routers will form neighborship and then only it will exchange routing information. If router don't have any neighbor, it will not send any update message. Done. And inside the hello message there will be one more information, like what value router 1 is using to calculate metric. So it is using bandwidth and delay to calculate metric. So router 2 should also use bandwidth and delay to calculate metric, then only neighborship will form. So there are two requirements. One is AS number must match, and the second requirement is bandwidth and delay. Whatever one router is using parameter to calculate bandwidth, same parameter should be used by other router as well. Delay. So both routers are saying I am using bandwidth and delay to calculate metric. Router 2 is also saying, brother, I am using bandwidth and delay to calculate metric. So can we form neighborship? Router 1 will say yes, we can form neighborship because we both are using same AS value, we both are using same component to calculate metric. So we can become neighbor. Getting my point?
Yes.
And after becoming neighbor, router exchange what? Routing information. Done, guys?
Yes.
Okay. So here on router number 1, on any router where I am running EIGRP, there are some troubleshooting command. First of all, how to verify which routing protocol is running? Again, show IP protocol. By running this command, you can see we are running which protocol? EIGRP AS number 20, and that's why we don't have, I think, any neighborship. So IP EIGRP neighbor, you can see there is no neighbor. There are no any neighbor.
Sir, do you have
Because
these
here-
commands in separate sheet or no?
No.
Okay.
You can practice. If you will practice automatically, these commands will fit in your mind.
I just want to know, like, because there is a lot of command, like how to. Just
I
want
will check if seats are available. I will share with you.
Okay, thank you.
Okay. So let me configure EIGRP 10 over here. No router EIGRP 20 and router EIGRP 10 and network 13.1.1.0.0.255. So IP EIGRP neighbor. Who is neighbor of router 1? Neighbor of router 1 is 13.1.1.3 means router 3. Yes or no? And on which interface this neighbor is available on fast Ethernet 1/0. Okay. And these are the timer: hello timer, hold on timer, update timer, SRTT, and RTO query count. These are topics of CCNP. Don't focus on these terms for now. Okay, so till now we had discussed there is one neighbor router 3 and other command is show IP protocol. By running this command show IP protocol, we can verify the routing protocol is running EIGRPS number 10. After that we don't have configure any filtering. None. Then EIGRP IPv4 protocol for ES number what? EIGRP IPv4 protocol is running for which ES number?
10.
ES number 10. Guys, k values, here we are able to see k values, right? So k values is nothing but the metric component. Like your k1 is bandwidth, k2 is load, k3 is delay, k4 is reliability, and k5 is MTU. MTU, we had discussed MTU as well while discussing OSI model. Yes or no? In TCP.
Yes.
So you can see by default it is using K1 value and K3 value. K1 is your bandwidth and K3 is your delay. K3 is delay. Then an SAP appear leave it, router ID, then distance. Distance is 90 for internal prefixes and 170 for external prefixes. So tomorrow I will show you, external prefixes as well. There is some concept of external prefix also in EIGRP. We will discuss that also. Then maximum path that this router can support, this routing protocol can support is 100 and maximum hop count is 100. This is by default. We can change it as well. Maximum hop count allowed in RIP was 15 only. Here by default it is 100 and here we can increase it as well. Then automatic summarization is enable or disable?
Disable.
Disable. Maximum path that it can support is 4. Okay, we are performing routing for which network? 13.1.1.0/24 and distance is 19. We had not discussed till now the external distance. After that, there is one topology table of EIGRP. Once EIGRP router will found any neighbor, it will keep the neighbor information in neighbor table. So IP EIGRP neighbor table, and after that whatever information it will receive from this neighbor, it will carry that information in topology table. So IP EIGRP topology. This is topology table of EIGRP. You can see it have installed all the prefixes which received from which router? Router number 3 from their neighbor. All 40 prefixes. And for all 40 prefixes we have metric. And now here EIGRP will run dual algorithm and it will calculate best path. It will calculate best path. Is it clear?
Yes.
This is EIGRP. Now we have more concept as well in ESGRP, or lots of concept like in CCNA there are some concept. After that we have lots of concept in CCNP, lots of concept in CCI, lots of concept of filtering, but I will try to make you understand at least entire things of CCNA here. EAGRP is an advanced routing protocol, brother. We have lots of things, so you have to practice a lot. Okay.
But in the real
Yesterday,
world, we do not do the EIGRP protocol. We are not using that one.
nowadays
Yes.
nowadays we are using EIGRP as well. Our, see, whenever we are connecting multiple branches, like let's say I have one branch in India, one branch in US, one branch in Canada. Okay, I want to connect these three branch on cloud. Through ISP I have connected these three branch, right? Now to connect these three branch together I can use EAGRP protocol there on the cloud. So
Yeah.
you will understand.
Mhm.
See, let's say I have one branch over here in India, one branch in US and one branch in Canada. All branches are directly connected through internet. Getting my point?
Yes.
Now this branch have some prefixes, this branch have some prefixes, and this branch have some prefixes. I want to exchange these prefixes. So here I need to configure any routing protocol. Yes or no?
Yes.
So here I can use EIGRP, and we are using EIGRP here. Okay.
Yes.
Anything else?
No.
Anything else, guys?
No.
No.
So this is how, this is a basic working of EIGRP. First, by exchanging the hello message, EIGRP build their neighbor table, and after becoming neighbor router exchange, update message. So we have multiple types of message in EIGRP as well. Like if I will talk about the RIP, so in RIP there are only one type of message, that is update message. As soon as you configure RIP routing protocol on router starts sending their update message directly their routing table. But EIGRP first form neighborship. After the first it will decide that router, means router 2 for router 1 will become neighbor or not. For that it will check ES number and the value, which value they are using for the metric calculation. If both will match, then router 1 and router 2 will become neighbor. After becoming neighbor, it will exchange the routing information. So we have some types of message in EIGRP. First type of message in EIGRP is hello message. Hello. After that, update message, then query message, then reply message, and then acknowledgement message. So we have these 5 types of messages in EIGRP. As you know, hello message is used to discover neighbor. This message is used to discover neighbor. Yes or no?
Yes.
Update message. Update message is used to share network information. Yes or no? Update message is used to share network information. Then query, reply, and acknowledgement. We will discuss these two messages in next class. Query, reply, and acknowledgement. For today, just we have discussed two types of message. We have compare RIP and EIGRP together. So we had we understand that EIGRP have list AD value than RIP routing protocol. So whenever a router receive same prefix from both domain, from EIGRP domain and RIP domain, so router will prefer EIGRP because of list AD value. Yes. Then we have discussed the metric calculation in EIGRP. Formula is 10 raised to power 7 upon list bandwidth plus total delay upon 10 whole multiplied by 256. So try to implement this formula guys by yourself. See, I am going to give you one task, but how I will give you task until and unless you have not performed the task of RIP. So which task you will perform if I will give you a new task today?
I will do it like tomorrow. I think is the last day I'm gonna.
So can you do parallelly two tasks?
Yes, I will do it like in Monday for sure.
Okay. Actually, this is question I am asking you that here I have one daughter, 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 and here I have one daughter. Like this. Or let's say not like this. Here I have one daughter and here I have one daughter. Let me use here I am using fast Ethernet link, and here let's say I am using serial link. Let's say this is serial link. Okay. R1, R2, R3, and R4. So R4 have one network 10.1.1.0/24. Can you calculate metric on daughter number 1 via both sides? Via this side also, what will be metric over here and what will be metric over here? Can you calculate this value? You already know how to connect serial link, how to connect fast Ethernet link. If anyone don't have serial link, you can let me know. I will add serial link in your GNS3. Can you guys calculate metric over here? On daughter number 1, what will be the metric for 10.1.1.0/24 network? Very easy.
I think I don't have a serial in my Genesis 3.
Oh, you don't have serial link?
I didn't see.
So I need to add then.
You want me to share my screen?
Actually, yes, yes, please here. This is serial link. I want this type of serial link. Please share your screen.
Okay.
Can I stop recording?
Yes.